In this example, we have a word problem that's going to involve velocity and acceleration coming from a position function. So we're going to have some questions related to velocity and acceleration. And the given information is we're going to have a position function. So here's the situation. It says, suppose a stone is thrown vertically upward with an initial velocity of 64 feet per second from a bridge 96 feet above the river, by Newton's laws of motion, the position of the stone measured in height above the river after t seconds is this. So this is our position function. Here's our initial velocity. Here's our initial height. And the negative 16 refers to gravity pulling down on it. It says where s equaling 0 is the level of the river. So that's our height of 0. So we're going to ask to find the velocity and the acceleration functions. But before we do that, let's just do a quick little visual of what we got going on. We have time related to height, and we have some sort of an initial height to it, and the object is going up and then coming back down. But when you graph it with respect to time, it's going to look something like that, right? So we'll come back to that. We'll kind of talk about how our graph and make sure our answers are making sense related to the graph. So we'll pull it all together. So first couple things we're asked to do is find the velocity and acceleration. So our velocity equation is going to be the derivative of the position function. So if we take the derivative of that, we're looking at negative 32t plus 64. And then if we do acceleration, which is the derivative of the velocity, we're going to get derivative of this is just going to be negative 32. All right, so those are our velocity and acceleration functions. So next question is, what is the highest point above the river reached by the stone? So highest point visually is we're looking at this point, which in a previous math class that we called that the vertex, and we had some methods to figuring that out. We have a little bit of a different method that we could use in Calc, and it has to do with the fact that at that point, our velocity is going to be 0. So then that means we can take our velocity equation and we can set it equal to 0. So that negative 32t plus 64, set it equal to 0. So we'll subtract the 64 over, so we'll have a negative 32t equals negative 64. We'll divide by that negative 32. We'll get a time of 2. So that is when we reach our maximum height. But the question is, what is the maximum height? Not when do we reach it. So we reach it at 2 seconds. So then we need to take our position function and plug in our time. So what is our position at 2 seconds? So we'll have negative 16 times 2 squared plus 64 times 2 plus 96. All right, so if I throw that into a calculator, that's going to add up to 160 feet. And that is our what? So we will hit a maximum height of 160 feet. Okay, so that would occur at 2 seconds because we know that our slope would be 0 at that point. All right, moving along. So it says, what will the velocity and acceleration be when the stone strikes the river? So we're looking at hitting the river. So hitting the river means our position function is going to be equal to 0. Okay, so that means we'll take this position function, set it equal to 0, and that's going to give us the time that it takes to hit that. And then we can plug that time into our velocity and acceleration functions, and we can figure out what those answers are. So let's take our negative 16t squared plus 64t plus 96, set it equal to 0. I can factor a negative 16 out of it. So then that's going to be t squared. That's going to end up being a minus 4t minus 6 equaling 0. And so I can actually get rid of the negative 16 since I'm solving. And then I could just have t squared minus 4t minus 6 equaling 0. So bad news is that that's not factorable. So we need to use quadratic formula to solve it. So t is going to equal, the formula is going to be negative b, so negative -4 plus or minus square root of that -4b squared minus 4ac. Our a is 1, our c is -6. And that's all going to be divided by 2 times our a, which is 1. All right, so we're looking at a 4 plus or minus 16 plus 24, which becomes 40, divided by 2. So if I plug that into a calculator, the calculator is going to spit out two answers. One of them is going to be 5 plus or 5.16, and then the other one's going to be negative 1.16. Right, so this one makes no sense. However, if we go back to the graph where we have a height of 0, it's going to be those points. So if I do bring that back a little bit, those would be our x-intercepts, but we don't want negative time. So that one doesn't make any sense. And so then we have where the amount of time that it takes for the stone to hit the water, 5.16 seconds. So what is the velocity at that time? So our velocity at 5.16 seconds, we go back to our velocity equation. So we have -32 times 5.16 plus 64. So if I throw that into a calculator, I'm going to get about -1.01 or 1.101.12 feet per second. So there's our velocity at 5.16 seconds. And then our last bit is find the acceleration at 5.16. But acceleration equation is just constant. So all the time, no matter what time I'm putting in, our acceleration is -32. And then our label for that is feet per second per second. So per second squared. Right? So there's our acceleration. Here's our velocity at that time. And I got one last piece of information, and that is when t equals 3, will the stone be speeding up or slowing down? And we need to justify that. So here's how we go about doing that. It's going to be comparing our velocity equation compared to our acceleration equation. And so we know that the velocity we stop moving at 0. So our velocity at 0 is at 2 seconds. So I'm going to draw a number line. And at 2 seconds, we know we hit a slope of 0, right? A velocity of 0. And our time only really goes from 0 to 5.16. Right? So this is a slope of 0. Okay. To the left, I can figure out my velocity by plugging in a value between 0 and 1 or 0 and 2. So if I plug in a 1 and I add that together, I'm going to get a positive velocity. That indicates that we're moving up. And our graph would agree with that, right? Because this is the 2-second spot. So from 0 to 2 seconds, we're moving up because we have positive velocity. And then from 2 seconds to 5 seconds, we should be coming down. We should have negative velocity. So if I plug in like a 3 into this and add this together, I'm going to get a negative velocity, symbolizing this whole section is going to be a negative. This whole section is going to be a negative velocity. Then I'm going to compare that to acceleration. So acceleration from 0 to 5.16, acceleration is constantly negative. So everywhere on this, we have negative acceleration. So here's what I'm going to do. I'm going to break up where that kind of critical point is where we shift our velocities. And I have negative acceleration and negative acceleration. So this is my justification with Calc, is if I have positive velocity but negative acceleration, they're working against each other. So we are slowing down in that time interval. So slowing down. And you can see that visually, that our object is slowing down as we get to our maximum height. Then when these are working together, velocity and acceleration, whether they're both negatives or whether they're both positives, that means we're speeding up. And the fact they're negative just gives us a direction to it. So we are speeding up during that section. And so you can see that where this object is going to start to move faster and faster and faster, and the graph's going to get steeper and steeper and steeper. All right, so question was, When will the stone be speeding up or slowing down? It's going to be slowing down between 0 and 2. And then when is it going to be speeding up? It's going to be between 2 and 5.6. Maybe one more time. So it's going to be slowing down between 0 and 2 because they're working against each other. And then from 2 to 5.6, they're going to be speeding up because they're going in the same direction. They're helping each other. All right, so that was a lot, but that was a word problem that involves all sorts of different questions related to velocities, accelerations, and then deciding whether things are increasing speed or decreasing in speed.